Welcome. This is a quick introduction of the domain-driven design capabilities of the Qlerify platform. The starting point is to apply event storming to identify domain events and arrange them on a timeline. Once we have aligned all stakeholders around the relevant domain events and their order, we can add commands, systems, actors, and read models to each domain event. To speed things up, you can generate suggestions for all the above by using generative AI. In this example, we will generate a domain model for a sales process with generative AI. We will enter a prompt and ask the AI assistant to suggest a business process and domain model artifacts. All these artifacts can be configured in the settings. Make sure to tick the box "Use past tense to describe events." We will use the following example prompt. The CRM process for a B2B SaaS company that is used in the standard setup in Salesforce CRM, where all the steps of the process are managed by the Salesforce system. Then we select the amount of cards and data fields we want to generate, and click on the button, Generate Workflow with AI, and wait for the AI assistant to finish. The AI assistant starts by generating the business process with all the domain events. Then it generates cards that represent some of the artifacts needed in domain-driven design. Finally, it looks at the process and suggests read and write models for each domain event. These data models can then be used to create aggregates that can be visualized with their associated entities. All the content created by the AI assistant can be modified. The next step is to look at the AI-generated sequence and adapt it as needed. You may need to edit the domain events, change the order of them, or add or remove some domain events. Or maybe you want to identify aggregate routes, systems, and commands. Click on each domain event and edit the systems and commands as needed. You can also edit the read and write models for each domain event, but this is covered in another video. It is important to tag each attribute as read or write, since this decides if the attribute belongs to the read or write model. Once you have done this for all the process steps, you can look at the process from the system perspective. Here you can see the roles, the commands that are performed on a system or aggregate, and the resulting domain event to the right. This view corresponds to the software design level of event storming. You can edit the commands, systems, and domain events from this view as well. Now, imagine that we need to develop a custom service that is not supported by the Salesforce CRM. So we want to break out a custom microservice from the Salesforce CRM system. Let's say that you want to manage leads in a separate microservice with some custom logic. The way we do this is to look at the domain events that are related to the lead entity and replace the name of the system with the name of the aggregate, lead service. As you can see now, the command is operating on the aggregate lead service. The next thing we can do is to create a separate bounded context for this new service. Let's call this leads generation. Now the aggregate is placed inside the new bounded context. Let's create read and write models for operating on this aggregate. Select the related domain event, go to the Data Models tab and click on Fact Table and generate it with AI. Then we generate dimensions with AI. Now we have the attributes of our lead visualized together with its associated entities. The AI-generated data model can be changed quickly by changing the attribute names or adding or deleting attributes. Now we can go back to the aggregates view and click the checkboxes for Show Data Attributes and Show Entities. As we can see now, we have defined the commands and their arguments and the attributes for the aggregate. There are also several related entities that are located in other bounded contexts, as indicated by the gray integration line. Once we are happy with the design of our microservice, we can go on and generate boilerplate code for this new API. In this version of the Qlerify platform, we can select between JavaScript or C# code. It is also possible to generate unit tests, a Swagger file, and select between several database engines. Based on these selections, we will get a template in YAML format, which we can edit. This YAML file includes the domain model for your microservice and acts as a detailed instruction to the AI assistant. When we are happy with the file content, we can press the button Generate API. The AI assistant will now create a file structure and populate these files with requested source code. The code can now be downloaded and uploaded to GitHub. To conclude, the Qlerify platform makes it possible to go from idea to a detailed software design and an executable prototype in a few hours. Thank you for watching. Sign up for free by clicking the link in the description and check out our YouTube channel for more videos.